Good day, I'm Maile Madziba. Welcome back to our channel. Today we're beginning with class test 4 of our CRR 123, which is the second chemical engineering module at the University of Pretoria. We are looking at part 1 of class test 4, and this is actually the 2011 version of class test 4. It says a large gas cylinder of volume 8.95 meters cubed contains N2 gas. The gas pressure on the cylinder is 87.31 kilopascals. It goes further to say atmospheric pressure is 87.21 kilopascals. The valve on the cylinder is opened to allow the N2 gas to flow from the cylinder. After a while, the N2 flow from the cylinder will stop and the cylinder is said to be empty. Please note the empty in quotes. Now the question says, what is the mass of N2 left in the empty cylinder? The temperature is 300 Kelvin. So now if we're going to be able to find the mass of the N2 left in the cylinder, we're going to need the number of moles of the gas, of the N2 gas in the cylinder. And if we're going to find the number of moles, we can actually calculate that. A simple equation to do is N is equals to PV over RT. So we can use this equation to calculate the number of moles and then use the molar mass of N2 to calculate the mass that's left in the cylinder. So now with that said, if we're going to use this equation, we're going to need the pressure and the volume and the R constant and the T. We know the volume we have is 8.95 meters cubed. The R is a constant and the temperature we are given, which is 300 Kelvin. So now what we need to calculate is the pressure. So please note that the pressure we're going to be using is not the pressure before the valve was opened. Remember, after the valve was opened, and it is said that it's empty, that means that the gauge pressure is 0 because there's no pressure that is coming as a result of the gas. So I can just note here that pressure gauge is equals to 0, right? So if the pressure gauge is equals to 0, it's a rule of thumb that one needs to know that if the pressure gauge is equals to 0, then the absolute pressure, which is the pressure we need for this equation, is equals to the atmospheric pressure, right? And the atmospheric pressure, we are told that it's actually 87, which is equal to, it's actually 87.21 kilopascals. So it's 87.21 kilopascals. So now we know that the absolute pressure we're going to be using in this equation is actually 87 kilopascals. And with that said, if we have that information, then we can calculate the number of moles. So I can just say N of N2, right, is equals to, the pressure is 87.21 kilopascals. Let me not write kilopascals. Let me not write units. Okay, multiply by the volume is 8.95. Is 8.95. All over R is 8.314. It's a constant. Multiply by the temperature, it's 300 Kelvin. 300 Kelvin. Now, if you use your calculator, you will find 0.311190 kilomole. So now we know that after this calculation, we know that there's actually 0.311190 kilomole of N2 in the cylinder, and we can just use an equation we know with the molar mass to calculate the mass of N2. So we can say mass of N2 is equals to the number of moles multiplied by the molar mass of N2 is equals to 0.31190 kilomole. Let me just lift it up a little bit. Yeah. Is 0.911190 kilomole, right? Multiplied by the molar mass of nitrogen is actually 28 kilograms per kilomole. And if you use your calculator, it will give you 8.71 kilograms. So it's going to give you 8.71 kilograms of N2. So now we have actually answered the first question that said that calculate the mass of N2 that's left in the cylinder. That is actually our question A. Now, after we are done with question A, we then have we go to question B of the same class test 4. And question B says, let me just put this here. Question B says, A very good vacuum pump is now used to remove all the N2 gas from the cylinder, right? Once this is achieved, is the cylinder really empty, i.e. containing no gas at all? So what is the gauge pressure on the really empty cylinder? So now in this question they are saying, remember that initially the valve was opened and at the end of that there was no N2 leaving the cylinder, but there was still N2 in the cylinder, right? And we did calculate the mass of that N2. They are saying now that they use a vacuum pump to actually pump out all the N2. And after they've pumped out all the N2, they want to know what is the gauge pressure on the really empty cylinder. So for us to be able to answer that, and it's important to understand that when a cylinder is filled with vacuum, there's basically nothing there. The pressure of the gauge is equals to minus the atmospheric pressure. This is actually a principle that one needs to know, that if the cylinder is filled with vacuum, which means it has nothing there, then the pressure of the gauge is equals to minus the atmospheric pressure, and we know the atmospheric pressure is actually 87.21 kilopascals. So we can just say it's equals to minus 87.21 kilopascals, right? So this is basically the gauge pressure, or another way to express it, you can just say it's a vacuum of 87.21 kilopascals. Basically it represents the same thing. So this then answers question B of our class test 4, and it takes us to question C. So this is question C now. In question C, they are saying the really empty cylinder, which is the vacuum cylinder, is now filled with a mixture of N2 gas and CO2 gas, right? And it goes further to say the final pressure of 70 psi gauge at 594 degrees Rankine is actually recorded. So it says that it also says that the total mass of the gas pumped into the cylinder is 62.44 kilograms. So they are telling us that that cylinder that had everything removed in it, and it was filled with vacuum, which means it had nothing in it. Now it's filled with a mixture of two gases, which is N2 and CO2. And this is actually the pressures and the temperature of that mix of that cylinder after they filled it with N2 and CO2. So, and we are also told that the mass of the mixture is 62.44 kilograms. So now the question is, what is the SG of the mixture, N2CO2 gas mixture in the cylinder? And we are also told that O2 at NTP is equals to 1 or 1.0. So now they want the SG of this mixture. So let me just put together an equation for SG. So we can just say SG of the gas mixture. SG of the gas mixture is equal to the density of the gas mixture of the gas in the cylinder, right, all over the density of O2 at NTP. So basically SG is the density of the gas in the cylinder, or the gas mixture, right, all over the density of O2 at NTP. So which means we're going to calculate two densities, one of the gas mixture and the other of O2 at NTP. So with that said, now we can start with the density of the gas mixture. There are a couple of ways of calculating the density of the gas mixture, but an easier way to calculate the density of the gas mixture would be, let me just put it in brackets, the gas mixture is equals to the mass, right, of gas mixture all over the volume of the gas mixture, right? So with that said, the mass of the gas mixture, we are told that is 62.44, so it's 62.44 kilograms all over. The volume, we know that the cylinder volume doesn't change, so it's still 8.95 kilograms per meter cubed, right? Is it kilograms per? It's 8.95. Its volume is 8.95 meters cubed, right? And then if you use your calculator, it gives you 6.98 kilograms per meter cubed. So this then becomes the density of the gas mixture at those conditions. Now, the second point, the second one, we then going to calculate the density of O2 at NTP. It's very much easier to understand that at NTP, the temperature of O2 is actually 273.15 Kelvin, and also the pressure is 101.325, because NTP is basically the normal temperature and pressure. So therefore, the density or rho of O2 at NTP is equals to PM all over RT, right? And we know the pressure is actually the normal pressure, which is 101.325, right? Multiplied by the M is actually the molar mass, right? And the molar mass of O2 is 32, 16 by 2, all over R, which is a constant, is 8.314, multiplied by the temperature, the normal temperature, which is 273.15. If you use your calculator, it gives you 1.4278 kilograms per meter cubed. So now we have two densities. We have the density of the gas in the cylinder. We also have the density of O2 at NTP. And based on this equation, we can actually easily calculate the SG of the mixture. And with that said, we can just say therefore the SG of the gas mixture, or the mixture in the cylinder, the SG of the gas mixture is equal to the density of the gas in the cylinder. It's actually 6.98, so it's 6.98, right, kilograms per meter cubed, all over the density of O2 at NTP. We calculated to be 1.4278 kilograms per meter cubed, 1.4278 kilograms per meter cubed, right? And if you use your calculator, it's going to give you 4.8886. So basically, this is the SG of the gas mixture at these conditions here. So this wraps up our first part of class test 4, and I hope we meet again in our next video.